What's up, academic physics? Welcome again to the Simpkins Physics Corner. Today, your lesson is about vector addition. A vector is something that has both magnitude and direction. So let's just do a little quick hit to see if you remember what all this stuff is. Let's match them up. A vector. All right, well, we got, let's see, a quantity with magnitude or a quantity with both magnitude and direction. Oh, yeah. So that one's going to go there. How about a scalar? Well, that is a quantity with only magnitude. So match it up. Magnitude. All right, that just means the size of a quantity. Like, what's the number that goes with it? Time interval, or time is going to be final time minus initial time. Distance traveled is going to be total meters the object moved. Remember, all the steps count. And then displacement is going to be distance from the starting point. So make sure you're really getting familiar with all those terms. Make some flashcards if you have to. Let's get into vectors. Today, what I want you guys to pull up is your note packet here. So we just did those 6 definitions at the top. I want you guys to follow along in your notes with this one and look at a couple of examples of how adding vectors together is going to help us organize what's going on with whether it's a trip, whether it's hiking, whether it's two velocities that are impacting one another, maybe you're driving your bike into the wind, whatever the case may be. We're going to see how these vectors add together. So the first thing we want to know is what a resultant is. So the resultant is the result of adding two vectors together. Not too bad, right? And it's drawn from the tail of the first vector to the head of the last vector. This is called the head-to-tail method. So if I want to add this green vector A and this red vector B, you notice that I drew vector A first, and then I started vector B. We call this the tail of the vector. We call this the head of the vector. All right, so we started the head of, the tail of vector B is contacting the head of vector A. So it's called the head-to-tail method, because you just draw one, and you keep your pencil on the page, and you just keep drawing the next one. All right, and if we add those two together, we get the result. So the resultant vector would be the brown one there. It would be the combination of those two. Let's see how this might look if we were to draw some vectors. I just have a little ruler here on your notes to help you out. It says you want to add 3 kilometers east. So I'm going to draw a vector 3 kilometers east. So I'm going to start there. I'm going to go 3 kilometers east. I'm going to draw my arrowhead. And you want to label your vectors so that you know what you're talking about. We're talking about meters, inches, kilometers. This is 3 kilometers east. And then it says you want to add that to 4 kilometers west. Remember, head-to-tail method. Just keep your pencil on the page. Keep on going another 1. Keep going another 1, 2, 3, 4. That vector has a length of 4 kilometers east. And what we find is if we add them together and we consider how far do we go from the tail of the first vector, that's right here, to the head of the last vector, over here, we find that our resultant vector, the result of adding 4 kilometers east and 3 kilometers east, is 7 kilometers east. So we label our answer there, 7 kilometers east. Maybe say, Mr. Simpkins, don't patronize me. This is too easy. Well, I'm just giving you a very easy example to start off with, so that when we see some harder ones, we can still have a way to deal with those. So let's go to the next one. You want to do 7 kilometers east and 4 kilometers west. So let's consider how the head-to-tail method informs us here. We want to do 7 kilometers east. So I'm going to start here. I'm going to go 7 kilometers east. If you don't remember your compass rose, never eat soggy waffles. Remember, north is up, north is up. As we draw on the page, north is up, east is right, south is down, west is to the left. And of course, we're going to label the sky 7 kilometers east. Then we're going to bring it back, in the words of the great prophet Pitbull. So we're going to bring it back from here. But when you draw the head-to-tail method, some people want to go all the way back to the beginning. That's not how you do it. You draw the first vector, you drop a point right there where you left off, and now we're going to go 4 kilometers, 1, 2, 3, 4. We're going to go 4 kilometers west. And so if I want to find out the resultant of adding those two vectors together, the resultant is from the tail of the first to the head of the last vector. And if we look at our little ruler, it looks like that has a magnitude of 3, and it has a direction of east. So 3 kilometers east. Here's where distance and displacement are different. You can see that the distance traveled, that's all the steps you take as we defined it initially here, right? So 7 plus 4 is going to be a distance of 11 kilometers. All the steps that you take count. However, when we consider displacement, this is our x initial over here, and this is our x final, and how far do we go to get there? Well, we only went 3 kilometers east. So that's the difference between distance and displacement as it shows up on adding vectors. So the head-to-tail method, again, just a quick review. don't pick up your pencil. So if I draw vector A and then I don't pick up my pencil, I go back vector B, there's your result. Okay, that's good. If I draw vector A, some people, what they want to do is they want to draw vector B all the way back at the beginning. Okay, that's no bueno. You don't want to do that. It's not how it's done. So look at this first picture. You want to go head to tail, and then you draw the result from the head, tail of the first to the head of the last. What you don't want to do is reset back at the beginning. You see how this is wrong, right? Vector B should be over at the end of vector A. That's not the correct way to do it. That's also not a good way to do it, because some people just draw it really randomly there. All right, so head to tail method. Keep that in mind. You want to not pick up your pencil. You just draw the first vector. Keep the pencil down. Keep drawing the next one, whether it goes in the same direction or the opposite. So let's look at a couple of these to review this idea of distance and displacement, and also to reinforce this idea. Now you have a little more room on your page than I do, so pardon me if mine aren't the best. If you have a ruler, the best thing to do is to use a ruler, so you can use the centimeters, like 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8, all that kind of thing. I'm just going to try to draw them in relative sizes. What do I mean by that? Well, for example, all right, if I have 8 kilometers south, all right, so here's 8 kilometers south, and then I have to go another 2 kilometers south. You see how I drew the 2 a lot shorter, right? Because it's only 2, it's not 8. And if I were to do the result there, that's really easy. 8 plus 2. All right, the 8 plus 2 for the distance is going to be 10 kilometers. And the displacement is going to be from where you started to where you finished. So the resultant, I'm going to pick a different color to indicate this. The result is from the beginning all the way to the end, which of course is an easy one in this case because they're going the same direction, 10 kilometers south. That's really easy. That's really easy. Same thing for the next one, so I'll let you guys do that for the east-east. Let's go down, though. What happens if I go 5 kilometers north? All right, so I'm going to go 5 kilometers north. Make sure you always label your vector. All right, you won't get lost in your vector diagram if you don't label your vector, so always label your vector. But remember, the head-to-tail method says that after I draw that first vector, keep your pencil down on the page and continue to draw. You're like, well, Mr. Simpkins, I got to go the other direction. That's fine. Or you can scoot it over to the side a little bit. That's fine. But we're going to go 5 and then like another 3. Why another 3? Because I need this to be worth 8 kilometers south. So for here, I pick another color for my resultant vector. Let's do purple. The tail of the first vector to the head of the last vector is right there. And you guys can, I'm sure, figure out that that has a value of 3 kilometers south. So the displacement would be 3 kilometers south. However, remember, distance, add up everything. Every step that you take counts. So the distance is going to be 5 plus 8. So the distance is going to be 13 kilometers. The one to the right of that would be similar, so you can try that out on your notes. Let's look at some crazy ones. Actually, I didn't get too crazy with you here. All right, let's just look at this next one here. We got 2 kilometers east. So we're going to go 2 kilometers east. We're going to label that 2 kilometers east. And then we're going to go another 5 kilometers east. But then we're going to come back because we're going west now. So we're going to go 6 kilometers west. Notice how I'm trying to draw everything to scale. If you don't know what that means, use a ruler and you'll see how these work. Okay. And so if I draw the resultant there from the tail of the first to the head of the last vector, you can see it's a little shouty. All right, because it's only going to go, let's see, 2 plus 5 is 7, plus 6 is going to be 13 kilometers that we walk total, but the displacement is only 1 because we have 6 and we have 7. So the displacement is going to be 1 kilometer east. All right, so that is a quick little hit on vectors. What I'd like you guys to do is those 3 pages in your packet. You got the notes for how to add vectors, and then there's 2 pages of practice for 8 examples total. And I want you guys to come back next time with those draw and the distance and displacement calculated for each example. All right, so pretty quick lesson today. As long as you finish up those 3 pages, you are all set to go, and you'll be ready for next time we come back together when we talk about velocity problem solving and vectors. Until next time, it's the Simpkins Physics Corner Vector Edition. V is for vector. Have a good one.